So first thing to do is to identify your A matrix. So A is equal to 8, 4, 3, and negative 4. And then B is equal to negative 101. So the first thing we have to do is find A inverse. And A inverse is going to come from 1 over the determinant, which comes from multiplying the main diagonal, subtract the off diagonal. So that's going to give you negative 32 minus 12. And then for the inverse, what we do is we switch the main diagonal. So we flip the main diagonal and then make negative the off diagonal. So you'll have negative 4 and 8 switch positions, and then your off diagonal will become negative. So negative 3, negative 4. All right, so that gives us that A inverse is equal to 1 over negative 44. And then we have our negative 4, negative 4, negative 3, and 8. Now, the idea is that the solution x will be given by A inverse multiplied by the B vector. So we're going to take all of this A inverse and multiply it by the B vector of negative 100 and then 1. So when you look at the matrix multiplication here, what you have is you have a 2 by 2 that is being multiplied by a 2 by 1. So the inner dimensions will cancel and you're going to be left with a 2 by 1 matrix. So what will happen is you're just going to have 2 rows and 1 column. You'll take negative 4 times negative 100 to get 400, and then negative 4 times 1 to get negative 4. For the second row, you'll have negative 3 times negative 100, so 300, and then added to 8. All right, that is still multiplied by the scalar multiple, negative 44 in the denominator. So again, this is going to give you your solution. So you have negative 1 over 44, and then 396, 308. When you distribute the negative 1 over 44 to both of these terms, what you'll see is that you get negative 9 and then negative 7. So this x, remember, represents the entire vector, which has x and y. So what you're finding here is that x is equal to negative 9 and y is equal to negative 7.